right, everyone, welcome to November's SF Node. We've got a couple great talks for you this evening. First up, we'll talk about some community events coming up. We've got Node School, Oakland and San Francisco on Saturday, November 12th at NPM. If you're interested in either learning more about Node and going through some of the workshoppers or using some of your great Node knowledge to be a mentor, definitely go check it out and sign up and be part of the community. Also, we have Waffle.js on December 7th. Waffle.js is a great kind of lightning talk venue where you buy a waffle and hear some great talks. We highly recommend it. And finally, next month, SF Node is going to be at NodeSource on December 8th. We are moving from our first Thursday of the month to the second Thursday of the month because of Node Interactive. So a lot of people will actually be in Austin, Texas. I don't know if tickets are still available, but check it out if you have a little bit of a travel budget and go to a great Node conference. Next slide. So our sponsors tonight. First and foremost, we have Twilio. Twilio's hosting our location and food and drinks. I don't know if there's anyone from Twilio that wants to kind of give a little blurb or anything. Yeah, no? Okay. And also NodeSource. I'm actually a new employee of NodeSource, just hired 3 weeks ago. But NodeSource is the place to go if you're looking for a more secure version of the Node.js runtime. We help companies deploy Node that might need a little bit more security, a little more options for higher compliance environments. So definitely come check us out, go.nodesource.sfnode. All right, next slide. Housekeeping, we just kind of went through that. So kind of skip that from there. So finally, so getting started, our first talk of the night. Oh, sorry, on that slide. So contact us. We are always looking for more speakers. Community meetups are a great place to get into talks and learn how to speak in front of the community, maybe before you get ready for big conferences. So you can reach us at our GitHub page at sfnode/sfnode. Open an issue, say, I'd love to give a talk. If you don't have an idea for a talk, you can hit us up there as well, and we can help you out with some ideas. You can also hit us up on Twitter at sfnode or via email at teamsfnode@gmail.com. And at the end of tonight, be on the lookout for our survey. We love to hear feedback from people that attend our meetups to make sure that we're doing the best job we can and have a meetup that you guys enjoy and get good content out of. So our first talk for tonight is Josh Staples, who is going to do a talk on Authy and Node and get into two-factor authentication. So turn it over, and away we go.
Is my mic working? Mic's not working. Mic's working? All right, great. That's weird. So let me open this up. Cool. So Twilio. Twilio.com is actually a voice video messaging API for communications around the world. Twilio bought Authy about 18 months ago. Authy was a Y Combinator specializing in second factor authentication, right? How many of you have heard of Authy? Just curious. A few of you, right? How many of you have heard of second factor authentication, 2FA? A few more of you, great. Okay, excellent. So Authy is a 2FA service, and we're going to sort of go over this product here tonight. So first, the agenda. I'm going to talk about what exactly is Authy, what does this product offer. Then we're going to actually do an Authy demo. We're going to talk about why 2FA, why it's important in today's ecosystem, right? And lastly, I'm actually going to do a live coding exercise. I'm actually going to implement Authy into a meme stack here on my local machine. And it's also a code base which is available on our GitHub repo. So you can pull it down, check it out, get 2FA running on a meme stack in under a couple minutes. It's pretty great. Cool, so first, Authy is a Twilio service. And what we offer is a multi-channel delivery mechanism for two-factor authentication, right? We have Authy 1 code, which is SMS and voice calls. All of you have probably used it. If you're doing SMS authentication with Uber, OpenTable, Twitch TV, all these mechanisms, this is actually the Authy service operating, right? We also have something called the Authy soft token. The soft token operates off of your mobile app, and its main benefit is it can be used offline. And lastly, we have our premier service called Authy One Touch. Authy One Touch is delivered over IP networks or data networks, and essentially allows people to choose approve or deny immediately and have that processed as far as 2FA goes, right? So a little bit deeper. So the token generation for Authy One Code was delivered over SMS or voice. So voice being you get a phone call, it reads out the numbers, you type the numbers into a form. I'm sure most of you have done this at some point in your careers, right? What's great about One Code is that no app is required, right? There's no smart app required. If a lot of your user base is in, say, third world countries where they don't have smart apps, they don't have smartphones, they can't afford smartphones, this is a delivery mechanism for those users. Additionally, what we offer as a product is a localized experience. If you have users in Brazil, Afghanistan, Iceland, Argentina, right? When they get a notification to their phone, what's going to happen is they'll get that notification from a local number, right? So a local carrier. You're not going to be getting notifications from some US number that just kind of weirds you out. So it's a great managed experience that we provide for you. Additionally, One Code's a great fallback for the soft token and One Touch products that we offer. So if something happens to your phone, you lose your phone, you need a phone replaced, you can always use One Code as a fallback for that 2FA process, right? The Authy soft token runs on our Apple phones, and what you get is this unique code, in this case, a 7-digit code, right? You take this code, you type it into a form, and it's your 2FA authentication. What's great about soft tokens is it runs through an algorithm, and that algorithm is initiated by a seed. That seed value is synced between your phone and our servers. So at any given moment, even if your phone is not connected to telecarriers or internet or anything else, you can still provide that seed, and our algorithm, this is an RFC, knows what that expected seed is supposed to be within a 20-second time frame. So you can demonstrate second factor authentication to a website with that process as well. What's great about soft token and our One Touch product is this is a solution we offer in our mobile SDKs. So if you have a website that uses iOS or Android, complementary applications, you can build this kind of functionality, this two-factor authentication functionality into your website as well. So lastly, our premier product, the Authy One Touch feature. It's very secure, it's over IP networks, there's no SMS, SS7 vulnerabilities that you may have heard from NIST or the like. It's completely configurable. The entire messaging screen there is configurable. You can add all kinds of text, you can add images, you can add any kind of contextual data that sort of allows the user to pick the correct answer, approve or deny this particular transaction. Additionally, it's a push notification, right? So it's over IP networks. It comes down from either the iOS or the Google Clouds. That notification hits your phone initiates Authy, and it creates a secure channel between your phone and our servers to provide that 2FA authentication. We also have HMAC callback inspection. So if you set up a callback, whenever you get a response to a 2FA to your server, you can inspect that response and make sure there's no man-in-the-middle attack. So it's a secure channel both to and from our API servers. And lastly, this is, again, additional feature that's built into our mobile SDK. The only caveat is that if you're going to be doing push notifications, you have to manage those push notifications yourself. If anybody here has used Firebase Cloud Messaging, GCM, maybe, it's so simple. I'd never used it before, and it took me about 10 minutes to figure out how to push notifications to a phone. It's crazy. All right, so before I get too far down the rabbit hole here, let's actually do a demo, and I can show you how this actually works. Great. So on the right side here, you actually see my Authy and messaging applications on my phone, right here. On the left side is one of our demo sites. We have banking, Owl Bank, we call it. The owl is sort of our mascot here at Twilio. The whole meme of sort of draw an owl, draw two circles, dot, 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 and you have a beautiful owl, right? So a lot of our programming challenges are exactly that. We want to do this, we start doing it, and after a long process, we get to the owl. So that's the sort of demo there. So I've already registered this user. I'm gonna log in. So this Owl Bank is protected by 2FA. So I initiate the user session. It says that username and password is correct. And I get a one-touch notification to my phone right here. Owl Bank user login. I know that's me logging in. I can click approve. Boom, I'm into the website. Now what happened there? When I clicked approve on the actual application here, It sent a callback to my meeting stack here. And the callback then connected to the client front end and said, this is actually Josh. He's demonstrated 2FA, allow him in, right? So this is my Albank site. I'm doing very well. I've got $1 million in savings, which is excellent, right? Only about 5,000 in checking, yes. I haven't bought any property in San Francisco yet, which is hence the balance. But there are many other things besides 2FA you can actually do, right? So for example, let's say some pirate or some hacker logged in the website at this point. Let's say they wanted to transfer $10 million. Looks like, oh, we'll do that, $10 million. Send to evildoer. Thanks for the cheese, right? So this is another example of transaction. I get this notification on my phone. It's 10 a.m. You know, I'm like, or 10 p.m., 2 a.m., whatever. I'm like, what? I'm not logged into the site. I'm certainly not trying to transfer money out of my bank. I can hit deny right there, right? One touch request denied back to the banking site. This is a transaction model of second factor authentication. If you look at the actual receipt information, you can see denied, great. Transaction ID, it provides that information too. But this is great for the actual servers, the people who are providing the service, is they can log this information, right? This is contextual analysis in a nutshell right here. If you take a look at this information and say, hey, there's a lot of fraudulent transactions happening around this particular user, maybe we should throw a flag, maybe we should call them, maybe we should lock down this account. It's a great use case for demonstrating security. And let's refresh this a little bit. So I've only shown one touch so far, but if we do something else, say, I'm gonna send $200 to my dad for mom's birthday. Right. So let's say I didn't have a phone application. I didn't have the Authy app. So we're gonna wait for the one-touch approval. I have a little timeout here after 5 seconds. And say, let's just send an SMS since I don't have the Authy app installed. I get the notification to my phone, 250-9363. Verify the token. Token approved. Great. Approve. Transaction approved via the time-based one-time password token. So cool. And what's neat about this is you can extend it beyond authentication and login, right? So I have another application here. We actually have a desktop app for Authy. Now this user is actually logged in as an entirely different person. I use a different phone number to create the registration. So you see this number right here. What we're going to do is create an escrow. This user is called Josh Dad, right, for this scenario. So I'm going to say, hey, Dad, let's set up a $1 million escrow for a studio apartment in Soma. Great. So the escrow, I got notifications both to Josh Dad here. This is our Chrome app. I'm going to say, oh, okay, yeah, we're going to set up that escrow. Both parties approve the escrow, right? You can see one of two parties is approved already. Second approves, boom, escrow is approved, the money's released in your bank, right? So there's a lot of different use cases you can use for the actual Authy data model. Cool. So that's enough of the demo. So why Authy? Well, it's a multi-channel authentication. You know, you've got one code, you've got soft token, you've got one touch. It's a multi-device support. You have iOS, Android apps, you can use iPad apps, and you also have your desktop, right? You can sort of sync all your keys between all these different applications. You lose your phone, you go to your iPad or some other application, you say, I lost my phone. Let's remove that from my trusted circle, right? It's a lot of great stuff. Additionally, if you say you do use your phone, it doesn't just disable the application. What it does is it rotates the seeds. Remember the algorithmic seed for generating the TOTP password? Does anybody remember RSA, the key fobs? About 5 or 6 years ago, I guess, somebody hacked their database, right? Their seed database. They had to replace 4 million physical key fobs for this RSA authentication, right? All we have to do is hit a button, change that actual seed value out. It's an incredibly secure process. We're REST-based, right? If you wanted to build a library, it should take you a few hours. It's really easy to do. I've done it myself multiple times for any kind of language. All you have to do is understand REST and be able to make a REST call from your stack. It's also a turnkey implementation. Like, I'm a solutions architect. I work with customers on a daily basis, helping them implement this. Typically, we see customers can do this kind of implementation within a couple days. Right. This is great. If you try and build this kind of stack yourself and put all this information in your own database, one, that's a security issue. Two, it's a waste of time and money. right? This is something that should complement your service. It shouldn't be using up your engineers on a full-time basis for a week or a sprint or two to try and figure this out. It's literally a turnkey solution. We also, of course, offer Android and iOS SDKs. So you can implement TOTP and one-touch into your application. Lastly, self-service, so user service approaches we take. We provide these kinds of solutions to your users, right? So if somebody changes a phone number, if somebody resets their phone, somebody loses their phone, we take care of that support for you, which is great. Additionally, as a security measure, if say a customer signs up with one phone number, goes and changes their own phone number somewhere else, we take care of that process for you and keep the associated ID from Authy sort of associated with that user, right? And lastly, the consumption model. If you guys have 1 million users in your database and you're like, we need 2FA, right? We need it now. Well, if you implement it, a lot of companies will charge you on a per user basis, right? If you have 1 million users, that adds up immediately. We do a transaction, it's consumption based. If you have 1 million users and one user uses this authentication process once, you pay for that single authentication, right? It's sort of a model that's designed to grow with you. It's an opt-in model, and we have a lot of people doing this. And it doesn't even have to be for 2FA, it can be for any other kind of transaction. Twitch TV is one of our customers. Anybody know Twitch? Yeah, right. You authenticate once a month with them, right? It doesn't even have to be every login. It's sort of defined by the actual application process. Cool. So why 2FA personally? Does anybody know this website, Have I Been Pwned? Who's on there once? Who's on there twice? Who's on there multiple times? This guy. Okay, hey, that guy back there too. Great. Yeah, 5 times. I think I'm on there 4. You got me beat. So Have I Been Pwned is a great little database. So if I were to type my email now, and this is operated by a security guy. I forget his name right now. But essentially what it does is it grabs all these data breaches, Yahoo, Adobe, Dropbox, all these massive multi-million user data breaches that are occurring, and it tells you when something's been compromised and if you're on that website, right? So this is me. I'm all over there. Like hackers, black hats, whatever, they know my passwords going back 10 years. Like these hashes weren't that great 5, 6 years ago. No, it's a problem. It's a problem for me. Additionally, I used to be a government employee. Yay. Part of that process is the Office of Personnel Management. What does that mean? That means they send you a bubble chart and call every one of your friends and learn every single detail about you for years, which is great, especially when all that information is hacked. Did I mention my fingerprints were also hacked? Because they're also hacked. So now some Russian hacker has my fingerprints, the name of my cat when I was a child, and my parents, maiden name. Wonderful. So I have literally no security possible unless I'm using like completely random generic passwords. But again, if that's hacked, I'm toast. So this is why I do 2FA personally. So as a provider, why 2FA? Well, obviously you want to be a good web citizen, right? This is a good, secure approach for you as a provider. You want to give your customers this potential possibility, right? You also want to protect your users. Does anybody here do phone support for their parents? Right? Do they call you up and they're like, I can't get into Facebook? And they're like, well, what'd you do? Change your password? No, it's the same one ever. 1, 2, 3, 4, 5, 6. Well, that's probably your root cause problem there. So this kind of prevents that kind of long-term support as well. It's just being a good web citizen. I'm not saying use Authy. I'm saying any friggin' 2FA product out there, implement it, build it your own, right? If you need a turnkey solution, we can help out. But just add this kind of second measure of security. It's 2016. We need to stop playing games with this. So great. So I'm going to actually show you guys, hopefully, how to live code and implement Authy on a website. So we're going to go over this way. This is WebStorm. Anybody use WebStorm? Yes, IntelliJ. It's a freaking great IDE. Before I do that, I'm actually going to show you this website. So this is anybody use Ngrok? Ngrok is amazing, right? I only found out about it 5 months ago. It's changed my life as a developer. So I'm going to show you guys quick, just a user session login, right? So if I try and go to this protected page, it sends me right back to login, right? It's saying you're not logged in. You're going to go back. You're going to be redirected to this web page here. Type Josh Pass, login, Now I'm into the protected page. It says protected by Authy. It's actually not protected by Authy. It's just protected by the user session. So let's go ahead and implement Authy protection on this website. So here's my sort of middleware express. And on the bottom here, I'm going to make this larger in just 1 second. I'm just getting positioned here. So IntelliJ has a presentation mode. Boom, right? Pretty cool. So the first thing we're going to do in this website is we're going to add the npm install Authy client. I've already done that. It's part of my package.json. Always use --save to save your package.json file. But subsequently, we're going to add that actual client to the website. So here's 001. Boom. I've passed in the API key. That's part of my environmental variables. This is something you'll get from the Authy dashboard. This is unique to your application. This is what lets us provide this 2FA protection, right? So we've created a client. We've created an instance of that class called Authy, right? So let's go to 02. So the first thing we're going to have to do is actually create the Authy ID. And let's copy this real fast. All right, so let's talk about this actual source. So what I've done here, this is a user registration function. And what we're doing is we're taking a password, email, an Authy ID, we're setting to null. We save that into the Mongo database here. And subsequently, we run this Authy.register user. And notice we're passing in only a few things. We're passing in the country code, we're passing in the email and the phone number. We only use the country code and phone number to create a unique Authy ID. The email is just there for support if people have problems, right? When you get the response from that, we're going to get back the unique Authy ID, and that's unique to you. Regardless of which site you go to, you're going to get that same Authy ID if you have the same phone number, you have the same country code. Then we're going to save that Authy ID into our user database, right? Our data model. So now we'll go to 3. So one thing we have to do is set up how the SMS sends. And I've already done all the front end stuff for this. We're just showing the back end right now. So now we're going to request an SMS. Notice we're passing in the Authy ID. Force is true, it's just saying send an SMS regardless if they have the Authy application installed. And then a response 200 saying, yeah, that works. Let's go down to 4. So one thing we do after we actually pass in the 2FA, after we send the SMS, we have to have some way to verify that token, right? So we're going to verify the token. So this is where a user types in the token into a web page. We know who they already are because they've logged in. They have this Authy ID. And we're going to pass the token and their Authy ID to this website, to our API servers. And if the token response is a success, that means they've demonstrated a second factor authentication. What we're going to do is then set this Authy equal true on their session. And you can apply this to the user as well if you wanted to persist a session with a cookie. But in this use case, we're just doing the session. So cool. So I have to drop out of presentation mode for 1 second. I haven't figured out how to switch files yet. Cool. All right. So now we're in our routing file. You can see the entire website. This is what starts up the server. We've got our connections to the Mongo database, all the different routes and everything else. And notice our protected route right here. It's protected by require login, right? So we're going to change this up a little bit. We're going to say required login and 2FA. And I happen to have stubs for that implementation right here. So require login. Let's grab this code. So now it's require a session login and require a session 2FA. If that's true, then we allow them to progress to the actual page. If it's just logged in and not Authy, then we say, no, you have to do a 2FA, right? So we'll send them to the 2FA page. And if it's neither, we send them to the login page. So lastly, we have to take this application right here and say, we're going to apply that to the protected page here, right? Cool. So I'm running Node Monitor right here. So it should say, hey, everything's kosher. Let's go ahead and reboot this. It's good. I'm actually going to close this. There you go. Try and go to the protected site, and it immediately forwards me to the login page, right? Because I'm not logged in. I just killed my session. Type in my username and password. Before I hit enter, let's actually move this guy over. There we go. Cancel out of that, and we're going to send an SMS. Josh Pash, login. sent to the token verification page. What I've actually done here is I've built out the 3 options we have. We have SMS, voice, or one touch. Since I just did SMS, we'll do SMS here as well. I'm gonna get a notification. Cool. 1241475. Verify the token, and boom, we're into a protected 2FA and login process web page. So what I've just did is I've demonstrated how to add 2FA to your website in under, I don't know, about 5 minutes. So again, it's a turnkey solution. It's really easy, really straightforward. And again, this entire demo is available on our GitHub page. We'll get to that in a second. So just to recap, Authy is a cloud-based REST API with multiple delivery channels. It's literally a turnkey solution. It's cake to implement this tool. If you actually go to our Authy SE site, there are some curl examples for what you can do. Everything is, you can do curl for every one of these operations from the command line with an API key. And additionally, we have the Node.js, AngularJS demo app, which you just saw. And again, if you guys leave from here with anything else, it's be a good web citizen. I personally don't care what approach you use, maybe a little bit, but use some kind of two-factor authentication, right? Just, it's so easy, it's so cake to implement your site. And that's it. Any questions? No questions. If you guys text this number on the bottom here, you'll actually get a bunch of links about today's content. We're using Twilio for that. That's part of our you know, it's part of our bread and butter. No questions. Going once. Yes.
So, as a user of the site, what can the user do to help the site know that they want two-factor?
Twitter. Just ask. We see it every day. Yeah. Yeah. I was using Steam the other day. I'm a gamer. And Steam was using this email authentication to send your code. And I'm like, we don't consider email a secure form of communication anymore. You know, if Gmail's not parsing it, someone else is parsing it somewhere. So I tweeted them. I'm like, you know, why don't you guys use some other mechanism? Email's not a secure form of communication. That's the best way. We see it every day, and we reach out to people every day for exactly that reason. Yeah. Any other questions? Shoot.
What's your opinions on forcing 2FA across all users versus giving them the opt-in and allowing them to choose?
Well, good question. I guess it really depends upon your use case. If you're someone like Twitch TV, yeah, make it opt-in, right? If you're a bank, you want to protect financial transactions, make it mandatory, right? It really depends upon your architecture, your platform, and your process. Any other questions? All right. Everyone's going to log in and sign up tomorrow, right? Yeah. Okay, good. If you guys want to talk to me, I'm Josh at Twilio.com. That's all I got. Thank you.
All right, everyone. So thank you so much, Josh, for a great talk. What we're going to do is we're going to take a quick 5-minute break while we kind of transition to our next speaker. So great time to get a little bit of pizza, a little bit of beer. But before you go, everyone's favorite moment is the dad joke. And we've got a great dad joke to highlight Halloween. You know, a lot of candy. So what's the best time to go to the dentist? 2:30. We'll be back in 5 minutes.
You set me free. Every time your hands on me, I wanna be ready to shine. I can't deny the feeling that you're giving me. You lit the spark that set a fire. Ooh, oh, no. Don't run away from your love. Don't turn away from the heart of the groove, from the way that we move. Kill the lights we can't lose. Kill the lights and look right at me. Close your eyes, you can see me bubbling and I feel. Kill the lights and touch my body. Close your eyes, you can see me bubbling and I feel. Come and spin me around, get lost in the sound. Close your eyes, you can see me bubbling and I feel. Touch my body, kill the lights tonight. Let's live our life. Tomorrow doesn't always come. Don't try to hide, let's have some fun. You can't rely on anything or anyone who fights the love you have.
All right, everyone, go ahead and take your seat. We'll get started with our second talk of the evening. All right, everyone. So second talk of the evening, Thomas Hunter is going to be talking about Node, Redis, and you. So please give a warm round of applause for Thomas.
Can you hear me in the back, just vocally? Okay, cool. Hi, everybody. I'm Thomas. I work at OpenTable, if you couldn't tell. My friend just asked me a second ago, he said, what's the difference between 2FA and 2LA? I told him 2FA is Two Factor Authentication. 2LA is when you hop on an airplane and you fly south for about an hour or two. 2LA is actually two-legged authentication. It's a dad joke. All right, cool. All right, so this is Node, Redis, and You, presented by me. I'm going to kind of take you on a journey of looking at some different situations. Things that you can do with Node and Redis will go from like a beginner, intermediate, advanced stuff. And oh yeah, of course, OpenTable, we're hiring, so you know, grab me afterwards if you like playing with microservices, Node, Redis, any of that stuff. Cool. Might just stand over here. All right, so first we'll look at a beginner use case, the proverbial user counter. You know, one day your boss comes up to you and says, hey, wouldn't it be cool if we could see how many people are visiting our website? And you're like, yeah, that would be cool. So here we go. First we'll look at a sort of naive approach. So this is a really simple way that we can do a user counter using Node. And so in this case, we grab the HTTP library. We declare a local variable called counter, set it to 0. And then with every request that comes into our application, we increment that number and then return it to the user. That sounds pretty simple. So in this case, you know, a user comes along, they get a 1. The next user comes along, they get a 2. Next user comes along, they get the 3. Everything's hunky-dory. Bob's your uncle. And I'm also responding with a PID here. And in this case, you can see that the process ID is always the same as we're dealing with a single application. However, turns out your application is like really big. No one's ever showed user counters before. It's taken off. We need to scale this application. And so, you know, here we're going to use Node cluster, and we're going to scale this to 2 different applications. So again, we're grabbing HTTP module. We're grabbing cluster. We're instantiating 2 items in the cluster, keeping track of this counter variable, and then incrementing as we go along. Unfortunately, as requests come in, we see the first time the number is 1, the second time it's also a 1, the third request you're getting a 2. You know, what's going on here? And of course, I'm logging the PIDs as well. And so we see that we're bouncing round robin between the 2 applications. And so they both have, you know, a different counter variable in memory. And so, you know, the data we're getting back is not what we expected. So whatever can we do to fix this? Let's first learn a little bit about Redis. And so here's a quick introduction to Redis. It's an in-memory key value store. It's pretty fast to work with since it's in memory. It supports a few different data structures types. It's got this really nice, simple philosophy. It's that if something doesn't exist, you don't need to create it first to be able to use it. So, for example, in normal JavaScript, if you wanted to increment a number by 1, you'd have to first declare it to 0, then you could keep incrementing it. But with Redis, if it doesn't exist, it'll assume a value that makes sense. So numeric operations, it'll assume a 0. Much like Node itself, Redis is also single-threaded, which I personally think is a useful feature of both these platforms. It makes things simpler to reason about and debug. Communication with Redis is pretty simple. Anyone here ever use Telnet? All right, got a few. All right, so Telnet was like this really old protocol where you could send messages over TCP. So you could literally use Telnet to send simple commands to Redis, then get information back. By default, authentication is disabled, and Redis is only listening on the local machine. This is the same behavior of, say, MongoDB, so you don't have to deal with user management and ACL stuff. It just kind of works out of the box. That said, don't take a Redis box without authentication, put it online, and accept a request from the public. There's a bunch of people who are doing that recently, and they all got hacked. And I think they got little messages in their Redis machine that say, please send me a Bitcoin and I'll decrypt your data. And of course, their data was deleted. You can also do expiration on a per key basis, which is pretty useful. So if you know you have data that expires after maybe 5 hours, you could set an expiration of 5 hours, assuming you're using it for caching purposes. That also has a cool feature called a global least recently used. And so if you strictly use it for a cache, which we do on my project at OpenTable, we'll set a global LRU. So that means we configure our Redis to use 2 gigs of RAM. Once it gets close to 2 gigs, it'll start deleting old data. We also have per key expiration. So we just never get data that's too old, and we never run out of memory. So using Redis is super simple. We do brew install Redis, assuming you're on a Mac, or if you're crazy like me, you can do sudo apt-get install Redis, and you'll get it running on your Linux machine. And so we get a command line tool called Redis CLI. It's nicer than using Telnet. You can do tab completion, command names, and stuff like that. So here, I'm doing some really simple commands. I'm doing a set. When we do the set operation, we provide the name of the key we want to set the data in, and then a string representing the data. We get an OK back saying it was good. I'll get the data. It'll tell me the data. I can delete it. It'll tell me one piece of data was deleted. And if I try to get that data, I get a typo for the word null. Just kidding. That's intentionally null. And then, of course, when you're done, you can just hit quit. Cool. And then, so I mentioned earlier the different data types. So this is the types of data that Redis supports. The first one is strings. This is just a simple key-value pair. And if your value happens to be a number, you can perform numeric operations on it, like incrementing it and decrementing it. And then, so anyone here use memcache? Okay, a few. And so in this regard, memcache is also an in-memory data key value store, and memcache supports strings. But these other data types, tools like memcache is not supporting. So another data type is called lists, and this will store an ordered list of data. Items can be repeated. This is similar to a JavaScript array. So with JavaScript, you can push to the array, pop from it, shift or unshift. Redis has the same operations, but they'll use different names. So there's lpush, lpop, rpush, rpop. And you can also get like the length of lists and stuff like that. We also have hashes, which is similar to a JavaScript object. So it's a key value pairs within a single Redis key. You can't expire individual properties, but you can expire an entire hash. So hashes are useful for keeping related data in a small place. And just like JavaScript objects, you can get and set individual properties and remove them. We also have sets, which is anyone using the ES 2015 sets in their projects? Nice, a few. So these only allow you to have unique pieces of data. And so you're not so much adding and removing as you add and remove instead of pushing and popping. And so these are unordered items. You can put things in them, take them out, see if it contains an item, but there's no real concept of order. We also have sorted sets. This is a fun one. So again, we have strings of data in here. Each one needs to be unique, but they also have the values for sorted sets are numbers. And so each number is it's referred to like as a score. And so a lot of social media games, they'll use sorted sets for keeping track of like high score lists. I used to work at DNA, rest in peace, they just went out of business a few weeks ago, but they would store all their data for high scores in sorted sets. And then in the most recent version of Redis, we get this geolocation data type. Under the hood, it's a sorted set, but that's just an implementation detail. You can do cool things like you can put in a latitude, longitude, and then some sort of identifier like an ID. And then you can very quickly query items that are within a certain radius. I use this extensively in some side projects, and I'm working on bringing it to OpenTable as well. And so how do we use Redis with Node? I'm glad you asked. We do npm install ---- save Redis. It'll stick it in your package JSON, of course, and then you can require it. And so here in this example file, we require Redis. We perform a create client. This will, connect to Redis and get us that connection. And then immediately after that, I'm doing a Redis.set. I notice that I'm not dealing with like a connection callback before I start running these commands. One nice philosophy with this, the default Redis package is that it'll simply queue up commands for you, and then as soon as the connection is done, it'll fire them off. If you wanted, though, you could put a callback in that create client and ensure that your connection was established. If you're just doing caching, you don't necessarily need to worry about callbacks. But if Redis is your primary data store, you would definitely care about something like that. So in this case, I'm using my Redis instance. I'm doing .set, and that refers to the Redis set command, of course. So the first argument is the key, the second is the value, and then I get a callback with whether or not that succeeded. Here I'm just assuming it succeeded. So then after that, I'm going to do a .get on that same hello property. I'll get the world back, and then I'll log it to the screen and just close the connection. That's pretty simple to work with. And so I bet you're all wondering how we can use this newfound knowledge of ours to fix our user counter. Well, here we go. So again, we're grabbing the cluster. We are grabbing our HTTP library, creating the Redis client now. We spawn off our two cluster servers. And then once the connections come through, we're going to run this redis.increment. And so in this case, I'm going to use a key called counter, and then simply increment it with each request. And like I mentioned earlier, it'll default to 0. So I don't have to do anything like set the value to 0 when we run this application. And so each time you request request one of these websites, you get the data back. It'll increment atomically, and there's zero risk that multiple users hitting the site concurrently will have weird results with the counter. We'll always increment 1, 2, 3. And so we see it working here, and we see our PIDs alternating back and forth. All right, so that was the easy stuff, beginner. Now we're going to look at a little bit more intermediate. Let's build a distributed task scheduler. And this is code I wrote for a side project. Really, I wrote it in a few hours, so this Redis stuff is pretty easy to work with. So first, again, we'll look at a sort of naive approach using Redis. So again, we create our Redis connection. Here I'm using these zadd commands. And so what this does is it adds data to those sorted sets that I mentioned earlier, the ones with the scores. So in this case, I'm going to add an item to our job queue. The score for this, I think is kind of clever. We set the score to the current time in milliseconds plus 5 seconds. And then so the work that we want to perform for this piece of work is to email the first user. And then I'll add another piece of data, and this one is for the same timestamp, but for 10 seconds in the future. That'll be to email user 2. And then within this application, I'm going to do a set interval. So every second, I'm going to ask Redis for all the work that I need to do at this point in time. And so imagine this application running on, maybe hundreds of instances. We have some high availability stuff going on here. So the first thing I'm going to do is, of course, get the current time. And so what this will say is, get me all the work that I need to do from, time 0, 1970, to this millisecond. And so the first command we do is z range by score. And so what that says is get items in the sorted set from the first number to the second number. So in this case, like I said, 1970 to now. And then we get that data, but we also want to remove that data from Redis. We don't want another one of our application servers to grab the same data and then perform the same work. So first we get the data, second we delete the data, and then finally we perform work with this. But there's a few drawbacks. Let's look at some console output. So another command that Redis gives us is called monitor. This is used for debugging. And so what you can do is connect to Redis, you issue monitor, and it will display you information about each command that runs. So in this case, I've color highlighted each of I'm running 2 servers, and so each server gets their own color. And so we see the first server comes along, asks for work. A few milliseconds later, the second server, the green one, asks for work. Then the red one asks for work. But then we have a race condition. At the same time, the red server and the green server are going to be asking for work. And we can see this on this line here and this line here. So you see how there was a pretty standard pattern going on, and then the pattern falls apart. So what this means is both servers at the same time ask the job queue for work to do, and then at the same time, both servers are asking to delete the work. And then once that happens, both of these application servers have grabbed the same piece of work. And so the console logs are written down below that. And so we see the first one gets no jobs, the second one gets no jobs, the first one gets no jobs. But then both the first and second application get the same job to do. And so we've emailed the same user, the same email twice. They're annoyed, they're complaining on Twitter. You lose your funding and your startup crashes. So how can we fix this? We can use these cool commands called MULTI and exec. And what these MULTI and exec do is they allow us to run multiple commands at the same time, atomically. So that means the 2 commands, there's no risk that different clients will be issuing commands in between. And so you can sort of think of this as a database transaction. And so the Node Redis library makes it really easy to issue these multi-commands. We do the redis.multi, and then that allows us to chain commands. So again, I'm doing that z range by score, z remove range by score, and then we get the data back and process them. And so here we see the new logs. So we see the first server asking for work, the second asking for work, the first asking for work, and we see there's no longer any risk that data will be duplicated. Pretty simple to work with. All right, now let's look at a more advanced use case. This one is going to perform a geolocation lookup. It's also going to look for data from a separate collection based on cities near another city, get that data, and then return it back to the client. So we get two commands with Redis for performing these sorts of operations. One is called eval and one is called eval SHA. So we just looked at multi and exec, which is pretty cool way to execute multiple commands sequentially. Unfortunately, there's a shortcoming with that, in that we can't take data, output data from one command and then pipe it into another command. So we have to run these non-chainable commands. So eval and eval SHA allows us to actually run Lua code on the server inside of Redis, which we can then do more programmatically interesting stuff. So the eval command, the way that works is every single time you run eval, you're sending an entire Lua script to the server, as well as the arguments, and then you're getting data back once it executes. But that can be a little bit heavy, sending the same script over and over with every request. So Redis gives us a second command called eval SHA, in which we send it a command, it'll hash the command for us, we'll just perform a SHA-1 against the file, and then we can refer to that script in the future using eval SHA and the hash. Managing all these hashes can be a bit of a pain. Luckily, there are libraries out there that'll make this easier for you. At least one of them is called Lured. A previous manager of mine wrote this. It worked pretty good for our use cases, and so I'm going to use that in this example. One sort of caveat with this approach is that you need a way to declaratively tell Redis which keys you need to get data from. So you need to give Redis all the keys ahead of time so that it knows where to get the data from. And so this isn't a problem if you're running a single Redis server, but if you're doing any clustering stuff, you have many Redis servers going on, and you're under the hood, it's putting data in different places. It'll use those keys to know where to get the data from. Yeah, and you can sort of think of this as a database stored procedure using eval SHA. All right, so this first file, this is a file called getcities.lua. Lua is actually a really simple language to use. I think it's simpler than JavaScript. It's a bit more performant as well. Fairly similar syntax. So when we declare variables, we use this word local. And so I'm going to declare a variable called key_geo, and that's the key that I use for getting the geolocation data in Redis. One thing you'll notice is that inside the keys array, I'm passing in a 1 here. And so Lua is actually a 1-based language, sort of like BASIC, which makes it a little different from JavaScript. And so I grab the key that I'm going to store geolocation data in. I grab the key that I'm going to store my actual city data in. I'm going to pass that in as keys too. I'm also passing other data into the script which aren't used for keys. And so that's the argv1, the argv2. That'll be the longitude and latitude which I want to query my database with. And so then after that, I'm declaring a variable called city IDs, and this will be an array of IDs for cities which match my query. So I'm going to run redis.call. We pass in the name of the command we want to run, in this case georadius. That's the one that gets geolocation data around a certain point. And so after that, I specify the key that I want to get the data from, then the longitude, then the latitude, and then the distance, the numeric distance, and finally a identifier for what unit I want to use. And then once I get that city's ID, I'm going to perform a hash multi-get. That's the HM get. And so that'll go to our hash, and then it'll look for different items within that hash, the different attributes, and then get the data for that. And so HM get is a command which takes many different arguments, one for each ID. And so in this case, I'm performing unpack on the city IDs. You can think of that as like the apply command in JavaScript itself. So then we get that data and return it back to the client. All right, and so there's a bit going on here, but I'll step you through it. So again, we instantiate Redis. This time I'm grabbing the file system module. I then declare my keys at the top so I don't have to repeat them all throughout the application. So my geolocation data will be in the city key, and then my city data will be in that data key. So we also define this object, called Lua. Of course, you can name it anything you want. And so this is a collection of key values where the key is a way to reference the script that we want to work with. And then the value is an object with an attribute containing script. Later, the lured module will mutate this object and will add a attribute called SHA next to script, and that's how we will refer to our scripts. So I grabbed the string for the Lua script, instantiate lured. We pass in our Redis connection and our that Lua object. And then I'm going to add some data so that we can actually find stuff. So I'm going to do redis.geoadd. That, of course, adds an item to the geolocation key. And then so that's going into the city collection. There's the longitude, there's the latitude, and I'm going to refer to this as San Francisco. And then I'm going to add item to our hash. So the redis.hset. The key is going to be San Francisco, and the value is going to be a JSON stringified object with some information about San Francisco. And of course, I'm going to do that again, but with Oakland. Oakland's a bit warmer than San Francisco. And then finally, I'm going to create this object called Berkeley. And so this is the longitude, latitude of Berkeley. And then finally, we're going to load the we're going to run load on lured. And so what that does is it takes each of these scripts, it sends them all to Redis. Redis hashes it, comes back with the data, mutating our object. And then once that's done, we're ready to use it. And so finally, I'm running redis.eval SHA. So the first argument for that is going to be the SHA, the command that we want to run. So we see it's lua.find.sha. The next number after that is the number of arguments which represent the keys being passed in. So on the previous slide, actually I'll go back, we see the keys 1, keys 2, argv1, argv2. And so that 2 here is how we differentiate between the two. So that means city and data will be provided with the keys object. And then after that, the Berkeley longitude and the Berkeley latitude will be the actual data. And then finally, we have our callback. And so what this does is it sends the data to Redis. Redis performs its super fast in-memory geolocation radius math, gets the data back to us, and then I do it. I just map through each item, parsing it with JSON, and then printing it out. And so we get an array of all the cities within 10 kilometers of Berkeley, which is, of course, just Oakland. So in conclusion, Redis supports some really cool data structures. Who knows, who's memorized all the big O notation and red, black trees and all that? I saw one thumbs up. See, I don't know any of that stuff, the hard computer science stuff. So the cool thing is we can just kind of shove all this data in Redis, and it's usually pretty performant for us. Of course, being in memory, it's pretty fast to query. You can use Redis to keep data shared across multiple node processes. Of course, you could use a more traditional database. You could be using Mongo and stuff, but if you have data that you want pretty quickly, especially cache data or session data, Redis is usually a better solution. You can use commands like MULTI and exec for performing simple atomic operations, or if you want more advanced operations, you can write Lua scripts and use eval and eval SHA. And if you want, you can download slides, and of course, follow me so I can get some internet karma. Does anybody have questions? Nobody? Shoot.
Sorry if I missed it, but eval SHA, is that like the built-in eval function in JavaScript?
Oh no, so that's so eval is a Redis command where we pass it a script, and then it will execute it on the server and then send the data back to us. Yep.
Is that Redis 3?
Yep, Redis 3.2 specifically came out maybe a month ago. It's pretty new.
there is an in-flight transaction, like a multi operation, let's say it takes a little longer, 2 seconds, 3 seconds. What happens to operations that read the same data is being changed? Do they wait?
Okay. So this question is, if we have like a long multi-operation running, what happens to other requests that are coming in? They get blocked entirely. So Redis being single-threaded, they would block. I think you'd be pretty hard pressed to get a 3-second multi command. However, if you do an eval SHA and you had a loop, going out of control, you could block that way. Anyone else? All right, I guess we're good. Thanks.
All right, thank you, Thomas. So that is the end of our talks for this evening. Next up, we have what we kind of call our 15 seconds of fame, where we open it up for anyone who is looking for a job, looking to hire at their job, have a cool open source project, have something neat they just want to talk about. Now's your chance to come on up, tell the whole crowd, and let the world know. Yep, come on up. You get to hold the microphone and everything, so.
I'm looking for a product manager. If anybody here has security experience, in Authy, we're expanding at a rate where I can no longer manage all of the different aspects of the product. We've got client products, we've got server side, we've got APIs, we've got all sorts of things going on. I need help. So if anybody in the room knows anybody or thinks they're up for the job, I'm very interested in a product manager, somebody who has a good few years of experience. Highly preferable you're in security, but I'll be willing to take a look at other areas of experience that you may have that would be applicable. So my name is Simon at Twilio.com. I work with Josh, so 15 seconds.
How's it going? My name is Ariel. I've been self-taught developer for about a year now, trying to teach myself. I'm looking for a job. I also started a meetup called Self-Taught Developers. We meet at Phil's Coffee, 24th and Folsom, every Wednesday at like 1. If anybody wants to work on anything, hang out, or whatever, I'll be free. Cool. So come chat with me.
Yeah. Yeah, don't be shy. Come on up. If you have more to say, we'll have a line, but just come on up, grab the microphone.
Hello, I'm Tara. I just graduated from Hackbright in September, so I'm looking for a software engineering role. I'm entry level, but I really want a job. I love coding. I love it. I love it.
Hey, my name is William Kepke. I contribute a lot to Node on GitHub. Maybe you know this or not, but there is a Node Foundation, and it has two openings on the board that are individual members. And last year at this time, they opened up nominations for that, and I just pinged them about starting that process again. One of the positions will be opening up in January, and if you want to run for it, put your name in, run for it, but most importantly, vote. Node is led by you, whether you like it or not. And so we need you to go and voice your opinion, look at the candidates that do run, and get somebody on the board that speaks for the community, and make sure that those big, giant corporate companies are staying in line on the board. So.
Hi, everyone. My name is Arnav. I'm a full stack developer currently looking for a job. I've built several full stack websites touching everything from databases to the front end using React and Angular. So if you need someone for the back end, the front end, everything, come talk to me. Thank you.
Hi, my name is Rich Trott. I do something called Node to Do. It's nodetodo.org, nodetodo.org. All you people who came up and said you're looking for jobs and so on and so forth, I would like to take advantage of the fact that you are not right now giving all of your intellectual efforts to somebody who's paying a paycheck. Node to Do is a thing that tries to help anybody get their first contribution into Node Core. That's the NodeJS, runtime. So go take a look. Ignore the part where it's all about like gatherings that we do in San Francisco. Just scroll down to where it's like, hey, here's how to get started, even if you can't make it to one of our gatherings. NodeTodo.org. Come talk to me. Thanks. Bye.
This is a little project I just made recently. It's been good for me learning just some stuff about Node and optimizing my code. It's algorithmarena.appspot.com if you want to play with it. What is going on here? Okay, there we go. So for instance, that's just an illustration of the difference in performance of using var versus let in your for loops on bubble sort. So I found this helpful in optimizing my own code, so I thought somebody might want to play with it. So have a look.
Hello, everyone. My name is Christian. Thank you, Joe, for putting this event together, and to all your team. Maybe you're a one-man team, I don't know. I was actually one of the organizers for JSConf Iceland that was hosted in August. We might be doing JSConf next year if anyone is interested, so stay tuned. We might be releasing some content in the next few weeks. So yeah, stay tuned if you want to experience JS awesomeness and come to Iceland at the same time. We have cheap flights now, so.
All right, anyone else? Any last people looking for jobs, companies hiring, cool GitHub projects you might want to talk about? All right, well, that is the end of our organized presentation. Please feel free to stay, hang out, chat, make a friend. We still have, I think, maybe a little bit of pizza, a little bit of beer. We're probably going to be kicked out around 9 o'clock, so just for a heads up, but otherwise enjoy and thank you for coming.